I'm going to briefly describe how we use an interactive simulation that looks at liquid-liquid extraction, essentially the Hunter-Nash method, on a right triangle ternary phase diagram. And so the simulation is located in the LearnChem site at this link. And what we're going to do is look at the simulation and observe some of its behavior. So here's the simulation. The feed, which contains all three components, a solute, a solvent, and a carrier that we're using to separate the solute from the solvent. Over a limited range, we can move the composition of the feed. And these three lines just show you how we measure the values, the mass fractions that we show here. And we have solvent down here, and then the raffinate, the final composition that we're aiming for. And so if we go to the mixing point, then what the simulation does is calculate, so the feed and the solvent enter the system. The mixing point is average composition. If we mix these two streams together, we get this from mass balance, and where this is located in the graph is related to what the relative flow rates are. These numbers are already specified in the simulation. Once we have the mixing point, we can determine the composition of E1, and we'll see what that is, leaving stage 1. Again, just mass balances. Then we can determine an operating point, again mass balances, as shown here, and allow us to show graphically the stages. So if we want to count the stages now, and we can use the slider to count the stages. So the first stage, so E1's leaving the system, solvent comes in, and then it picks up solute, and the feed comes in, and it loses solute. So we have E1, we have R1, we go back, right? This is how we determine P, and now we can count stages where E1 is in equilibrium. This is just the tie line, the orange line. We can then determine E2 using, again, mass balances. Allows us to get R2, the next stage, and we can keep stepping through the number of stages in the system. The simulation has some directions on how to use it, details on the mass balances that we're using here, and if we want, we can add grid lines to the system. So the idea of simulation help you understand the Hunter-Nash method on a right triangle phase diagram.